Okay, so this is the last part for arithmetic sequences, and as I referenced a few times in the previous videos, there is a different formula to write arithmetic sequences. So what you did previously was called the explicit formula. The explicit formula will tell you any term, if you have the formula, it'll tell you any term, any value for any term number that's in the sequence. The recursive formula is a little different. So the second formula type is called recursive. The word recursive kind of means, what does it sound? It sounds like reoccurring, things that happen over and over again. And that's kind of what the recursive formula does. It kind of goes back and forth, kind of looping back to get you to the next term. So what does that spiral really mean? Well, it uses the previous term to find the next term. So the recursive formula uses the previous term to find the next term. All right, so that kind of sounds like what an arithmetic sequence is. The arithmetic sequence is just using the common difference to get to the next term. The recursive formula just kind of formalizes that same idea. So in the recursive formula, there's two parts to a recursive formula. The first part is that the first term has to be identified. The first term has to be identified. So you have to tell, when you're writing a recursive formula, you have to state what the first term is. And then there's another term that has to be stated. Okay, and this one's a little different. Okay, so we know the first term, a sub 1. We did that. That's in the explicit formula as well. You're also going to have another term value that's called a sub n minus 1. Okay, so lowercase a, and then the subscript is n minus 1. What a sub n minus 1 means is it means it's the previous term. Okay. So if the term we're looking at is term n, well, the term before n would be n minus 1, the previous term. So this will make more sense in a second when we write the formula. So the recursive formula kind of has two parts to it. And a lot of times it'll be written inside of a curly bracket. All right, so we're going to have a kind of a big curly bracket. The first part, like we said, the first term has to be identified. That's going to be the first part of your recursive formula. The top equation is just going to be a sub 1, the first term, equals whatever the first term equals. Okay, usually that'll be a number. So it'll say a sub 1 equals 10. Okay, that means 10 is the first term. The second part of the recursive formula is how do you find the nth term? Okay. Well, to find the nth term, you would take the previous term and then add the common difference d. Okay. So what this states, kind of, again, this is the symbolic version of it, but what it actually states is that a sub n is the next term, is equal to a sub n minus 1, which is the previous term, plus d, which we already know from the explicit formula is the common difference. So a sub n equals a sub n minus 1 plus d. That means the next term is the previous term plus the common difference. Okay. Now there's a couple things I want to make note of. I should say that this is the recursive formula for an arithmetic sequence, because you can have recursive formulas for different types of sequences as well, and it's going to look a little different for those. So I'm going to specify that this is for an arithmetic sequence. And then sometimes for the second part of this, so a sub 1 equals a sub 1, the first term equals the first term, that's going to be the same for every single one. Sometimes you'll also see a clarification on the second part that'll say for n greater than or equal to 2. Okay. And that's just kind of like a domain value, where you're saying, all right, this formula only works, this bottom equation only works for the second term and above. Okay. So remember, n is a positive integer representing the term number. So this only works for the second term, the third term, the fourth term. Basically what it's saying is, don't use this formula, don't use this bottom formula to find the first term. Okay. If you need to know the first term, you want to use its top formula. Okay. So sometimes you'll see that clarification for n greater than or equal to 2. Okay. It's not really necessary because it's implied, but it is the formal definition. Okay, so let's look at an example for using the recursive formula. Okay, so this example says, write the recursive formula for the arithmetic sequence of 7, 20, 33, ... Okay. All right, so writing the recursive formula, we're just going to use the same format that we have above. Now, parts of this formula are always going to be the same. This part is always going to be the same, and it's always going to be just as it's written. So only things we need to fill in for the recursive formula is we got to figure out what A1 is, and we just got to figure out what D is. Okay, and those green circles are the only things that we're going to be filling in. The A sub 1 and the A sub n, those are all going to stay in the formula. Okay. So those are kind of like having y and x in your linear equation. So let's write our curly bracket. Remember, A1 is always going to stay there. AN equals A sub n minus 1 is always going to be there. And then all we have to do is, again, identify the first term and identify the common difference. Okay. And we'll put the plus in here too, because it's going to be plus D. Okay. All right, so A sub 1 equals, well, it equals what the first term equals. The first term is 7. Okay. So we just state that. A sub 1, the first term, is 7. All right, that's the first part. The second part is, again, the next term equals the previous term plus D, the common difference. We got to figure out what the common difference is. Okay, and all that is just figuring out what the pattern in this sequence is. How do you go from 7 to 20? How do you go from 20 to 33? This has a common difference of 13. Okay. So we're just going to plug 13 in at the end here. And that's the recursive formula. Okay. That's it. Again, all you're doing, for an arithmetic sequence at least, all you're doing is plugging in the first term and the common difference. Let's try one going the other way. So this next problem is going to be, we're going to be given a recursive formula and we have to write the first couple terms. Okay, so let's look at those. All right, so this one, given the formula, write the first 4 terms. Okay, and our formula is, again, what do we have? We got 2 pieces here. We have A sub 1 equals negative 3, and A sub n equals A sub n minus 1 plus 2. Okay, and we're trying to find the first 4 terms. Okay. The first term's easy. The first term is just given to us. A sub 1 equals negative 3. So your first term, what that means is that your first term is negative 3. Okay. So once you have the first term written down, that first part of the formula is done. We don't need it anymore. What we need now is the rest of it. Okay. Remember, it's the next term equals the previous term plus 2. Okay, the common difference is 2. So all that means is to get to the second term from the first term, we're just going to do plus 2. Okay. So negative 3 plus 2 is negative 1. Negative 1 plus 2 is positive 1. Positive 1 plus 2 is 3. Okay. And that's it. All we did was identify the first term, and then identified the common difference to give us the next terms. Okay. So the previous term plus 2 will give us the next term. Okay. So doing this for arithmetic sequences is pretty easy. You can use recursive formulas for non-arithmetic sequences as well. We're going to see here. Okay. So this next recursive formula tells us, again, the top half tells us that A1, the first term, is 20. And the bottom part tells us that the nth term is equal to 3 times A sub n minus 1. And remember, A sub n minus 1 just means the previous term. So what this means is that the next term is going to be equal to 3 times the previous term. Okay. So if we know the first term, we can find the second term by doing the first term times 3. And if we know the second term, we can find the third term by doing the second term times 3. So that's what this pattern is going to be. Okay. Try and find the first 4 terms. And the first one's given to us. First term is 20. Okay, again, that's A1. If you want to find A2, you're going to have to do 3 times the previous term. So that's going to be 3 times the A1 term. A1 was 20. 20 times 3 will give us 60. If you want the third term, you're going to have to do 3 times the second term, which is the one before it, 3 times the previous. So 60 times 3 is 180. And then to get to the next term, 180 times 3 is 540. Okay. So again, once you figure out the pattern, then it's easy going. All right, so that's a different type. That's not an arithmetic sequence, but it's still using a recursive formula, which is the skill here. All right, we'll do one more. This one's also not arithmetic. And this one's kind of long. So we know the first term, and we're trying to find the other 3. And again, to find the second term, you first need to know what the first term is. The first term is 4. And then to find the next term, we're going to kind of have to decipher this. 5 times a sub n minus 1 minus 10. So what this means is, again, it's going to be 5 times the previous term minus 10. So again, we know A1 was 4. A2, the second term, is going to be 5 times the previous term, which is A1, minus 10. The third term is going to be 5 times the second term, the previous one, the one before 3 is 2, minus 10. And same thing with the fourth term. The fourth term will be 5 times the previous term, which is A3, minus 10. Okay. So once you know all these values, then it's just plugging things in. We know A1, so we're going to plug it in. Okay, so you just do 5 times the previous term. So 5 times 4 is 20. 20 minus 10 is 10. Okay, so plug that in. So the second term is 10. Well, once we know the second term, we could plug it in to find the third term. 5 times the previous term minus 10. Okay? So it would be 5 times 10, which is 50, minus 10, which is 40. And then once you know the third term, you could find the fourth term by plugging that in. Okay? 5 times 40 is 200. 200 minus 10 is 190. Okay? So again, all it is being able to figure out what the pattern is going to be and then plugging it in. Okay, this pattern was 5 times the previous term minus 10. So we'll start at the first term that's given, and then use the pattern to find the rest. Okay. And that's all recursive formulas is. It's a little easier. A lot of people think, what's the point of doing this? It does have its benefits. But that's it. Again, when you're writing it, all you need to do is fill in the first term and the common difference. And when you're given the formula and you have to write the terms, start with the first term, figure out what the pattern is, and then go from there.